Alright, so general form for exponential growth, we have A, which is the initial value, or the starting value. That's also known as our y-intercept, and that's when x equals 0. So our b value is b, or when it's greater than 1, we have growth. And what the b value is then is our growth factor. And the r value is known as our growth rate. And to find that, we have r equals the b value minus 1. So if you look at the example here, our a value is 3. Our b value is 4. So we have a growth factor. So our growth factor is 4. And our r value, or growth rate, is 4 minus 1, or 3. And that's our growth rate. So we have an a value, or initial, or y-intercept of 3. Our b value, or growth factor, is 4. And our growth rate is 3. If we look at our second one, our a value, or y-intercept, or initial value, is 7. Our b value, is 1.5, so we have a growth factor, so that is the growth factor. And our r value, or growth rate, is 1.5 minus 1, or 0.5. So 0.5 is our growth rate. So our growth rate is 1.5, our growth factor is 1.5, and our initial, or starting, or a value is 7. Now we have the general form of an exponential decay function. And again, our a value is the initial, or y-intercept, and it's when x equals 0. Our b value is decay. So when it's in between 1 and 0, it's decay. And so then our b value is our decay factor. And our r value is the decay rate. And to find that, it's 1 minus b is equal to our decay rate. So in our example here, our a value is 4, or our initial value, or starting value, or y-intercept. Our b value is 0.6, so that's our decay factor. And our r value is going to be 1 minus 0.6, or 0.4, and again, that's our decay rate. Decay rate. Alright. So now we have the second one, and again, our a value is 9. Our initial, or y-intercept, is 9. Our b value is 1/3, and again, that's our decay factor. And our our r value is 1 minus 1/3, or 2/3, and that again is our decay. Our decay rate. So our decay rate is 2/3, our b value is 1/3, and our a value is 9.